please for 5 minutes, because
Okay.
you know the students, you know, they take a lot of time in joining, but they are joining.
Yeah,
the participant clock is ticking actually. 45, 46, 47, 48 like.
Yes, yes.
Yeah, it's interesting. Bikram, you have to adjust your camera a bit probably. You're only
actually when I am tilting it down, it is just going out.
Okay, okay.
So
then probably you have to move up. I mean, yeah.
Up. Now it's gone. It's gone.
Yeah.
Again, it's gone.
I know. Oh, sorry. This one. Okay. Not bad.
Let us check our video also. So I'm just checking my video. I'm okay, Dr.
Yes, sir. Yes, sir.
Yes, Dr. Sobi. Yeah, I can see Dr. Bikramjit. I can see Dr. Sobi. I can.
Namaskar, sir.
Yeah, no, I can see Dr. Siba also. Thank you.
Sir. So is it okay to put University of Hyderabad logo in the background?
No issue.
No issues. Okay. It's a virtual background, but still, I'm at home only.
You are at home. Oh, virtual background. Great.
Yeah, it's a virtual background.
So
Bikramjit, can we start? No, we have 58, 60. Yeah, 60 participants.
It's more than, it's almost 5 minutes gone.
Yeah, they are joining. Yeah,
okay. Shall we start, sir? Okay. Then we are starting, sir?
Yeah, please.
With your permission. Okay.
Yeah, please.
Good evening to one and all. Good evening, Director, sir, Professor Dr. Atmanand. Good evening, Professor S.K. Udgata, our today's resource person, who is commonly known as Udgata, sir, among his students. Good evening, Dr. Souvik Banerjee. Good evening, my faculty and non-faculty colleagues, all stakeholders and my dear students. Today, the business definitions are changing by adopting new technologies. Thus, IT has become the backbone for almost all transactions. No touching, social distancing are new concepts for all of us. Today, technologies like industrial IoT, big data, machine intelligence are in the forefront runner of any business activity. People have realized that in COVID period, sustainability depends upon adopting these new technologies as quickly as possible. Industrial IoT and machine intelligence are supportive tools for all sections, especially in the health sector in COVID times. Today's webinar will focus on these concepts and will give us many insights on public health management during the COVID. With these words, I now request Dr. Souvik Banerjee to introduce our director, Professor Dr. Atmanand, and welcome him for his most awaited and motivational inaugural address. Dr. Souvik Banerjee.
Thank you, Dr. Bikramjit. Professor Dr. Atmanand is a renowned economist, administrator, and academician. Currently working as director of MDI Murshidabad, he has worked as director additional charge of MDI Gurgaon. He is also the independent director of Central Bank of India and PTC India Limited, and was also independent director of CEL. Dr. Atmanand's experience in teaching, research, and consultancy is of more than 34 years. He is one of the longest serving deans of India. He has taken many new initiatives like the launch of the MDI School of Energy Management, Journal of IMT Ghaziabad, and established MDIM, to name a few. He has contributed to various national responsibilities as member of the State Finance Commission, Government of Bihar, Planning Commission, Government of India, and as member of Ad Hoc Task Force, that is ATF, Cabinet Secretariat, Government of India, member of Review Committee, Ministry of Ayush, Government of India, member of Advisory Committee, Ministry of Power, Government of India. Dr. Atmanand has authored 16 books and published more than 100 research papers in refereed national and international journals. He has undertaken several consulting assignments in area of energy, insurance, infrastructure projects, social development, leadership, etc. He specializes in public enterprise management, management of energy and environment, power, oil and gas, steel, financing infrastructure, projects, project finance, economic and business environment, public policy and management. His contribution of many years has been recognized in the form of awards like Rashtriya Gaurav Award for his excellence and contribution in nation building, Indian Achievers Award for corporate leadership in 2010, Economic Development Award for excellence in higher education 2011, Exemplary Global Leadership Award 2010, and appreciation letters from various departments like the Ministry of Power, Government of India, and CEL. Professor Dr. Atmanand's vision statement is to have people around him who are thinkers and doers in one person. He spreads the policy of connect, nurture, and grow. So we welcome you, sir. Director, sir, over to you.
Thank you very much, Dr. Savi. Now, good evening, everyone, my dear students, faculty members, staff members, Dr. Bikramjit and Dr. Savi, and Dr. Siba Kumar Udgata. First of all, I appreciate the effort put in by Dr. Bikramjit and Dr. Savi together in organizing this webinar and invited Dr. Siba for this webinar talk. We are indeed grateful to Dr. Siba for today's evening webinar talk on a very, very important topic. Welcome to the family of MDIM Murshidabad. MDIM's vision is to be an internationally excellent business school known for our academic ambition and influence in building a responsible future for both business and society globally. With an intention to impart quality management education, nurture talent, and groom them to become visionary leaders and game changers, the MDI Society had established its second campus at Murshidabad in West Bengal. After laying off the foundation stone in October 2010 by the then President of India, Bharat Ratna Shri Pranab Mukherjee, MDIM has not looked back. It commenced its flagship academic program, PGPM, in 2014. We are highly focused to create an ethical, knowledge-centric culture that values outstanding academic excellence, training, research, and consultancy. We are leaders in our field as we have progressed with Bloomberg Finance Lab, e-library, online courses, online MDPs, new courses like artificial intelligence and machine learning, business analytics, HR analytics, digital marketing, and entrepreneurship, to name a few. They provide us an edge over others. It gives me immense pleasure to announce that we were awarded A double star at national level and A triple star at state level by CRISIL in the year 2020. MDIM was also ranked #1 in the category of emerging business schools in India in the year 2019 by NHRDL. We also become a member of the Association of the Management Development Institutions in South Asia, MDISA, starting April 2019. In the past year, several initiatives have been taken at MDIM. We have taken steps to increase our international outreach by developing educational ties with SAARC countries. The Institute had signed several MOUs with Maharatnas, Navratna, and private companies to do joint training program, research, and consulting, along with enriching educational progress. We have signed MOUs with international universities for summer immersion programs for the benefit of students. Today, in this webinar, we have with us Dr. Siba Kumar Udgata, who will share his valuable experience on industrial IoT and machine intelligence for public health management during COVID-19. Dr. Siba Kumar Udgata is a professor in the School of Computer and Information Sciences, University of Hyderabad, Institute of Eminence. He served Center for Modeling, Simulation and Design, CMSD, as a director from 2012 to 2016. He also worked in the United Nations. His research focus is on intelligent algorithms for wireless communication, mobile computing, sensor network, and applications. He has worked as principal investigator in many funded research projects in collaboration with Stanford University, University of California, IIT Delhi, and few others. He has also published several research papers. So welcome, Dr. Siba, for your very enlightened, we expect and we look forward to your very thought-provoking and enlightening insights on a very important topic for the benefit of the participants as well as the students. Thank you very much. Over to Dr. Siba.
Yeah. So thank you, Professor Atmanand, and thank you for a nice introduction. And I hope I'm audible to everybody. And
Yes.
Thanks Vikram, thanks Souvik, thanks the entire management of MDI Murshidabad. And I heard a lot about it, but today I got an opportunity to interact with your faculty, with you, sir. And it's a pleasure to be with you, with all of my colleagues there. Now, yeah, it's a good time, Saturday evening. So please give your 1 hour time to me, and we'll discuss something which probably is of interest to you. So I was just, before the meeting starts, I was just telling that I'm basically a professor in computer science. So doing some research in computer algorithms, intelligent algorithms, wireless communication, sensor networks, and blah, blah, blah. And then we also have undertaken some sponsored projects sponsored by Government of India, IBM India Limited, and few others. The basic idea is that we have learned from all these projects quite a lot, which I didn't learn from the books. I learned when I was executing projects, project management, leading a project, leading a group of students, leading a group of scientists. It's not an easy job. Everybody has a good brain to think of, and we argue, we differ, but we conclude also. So that's a good thing I learned, which I didn't learn while I was studying computer science. So I learned this particular thing. And this international collaborations also gave us some scope how to think and how to take your research to a deliverable product actually. So that was not, particularly in India, we are not good at that actually. So the international universities, or when you go for an international collaboration, we feel that they are more oriented, or they are more focused on the finishing line. We are more oriented about the process, but they are more oriented towards the finish. They say that, okay, we have to finish like this. There is a time bound. How do we manage another thing? That's what also I learned. On my own capacity, I also served different business schools, business institutes. In some capacity or other, I work in some committees of IIM Sirmoor. I'm associated with my School of Management Studies here. So when this COVID started, right? In the month of, by end of February, mid of February, we were knowing that it is coming, and by mid of March, everything is shut down. It's all going on, and then we are sitting at home. We started looking at like what people are doing, what the world is doing, what we can do, or what we have been doing, how we can convert that, redesign that, re-engineer that a bit, so that this also can be fine-tuned, or this also can be used for managing the COVID-19 situation. So in the process, I and a couple of my students with a couple of my colleagues, we also did a lot of work. In fact, towards my end of my talk, we also wrote a book very recently, and the book was released by Springer, published by Springer last week only. So I'll also talk about that a bit. So please allow me to share the screen, and then I'll carry forward the journey. So,
Congratulations, Dr. Siba,
yeah, just a
for
minute.
the publication of your book. Congratulations.
Thank you, Professor. Thank you, Professor. Yeah, yeah. So the screen is visible, right? Yeah, fine. So it's a challenge for everybody actually, right? I'm looking at a laptop and speaking as if I'm speaking to hundred participants sitting in the conference or in the auditorium room, but that's okay. That's how the challenge is, and you have to come out with this. So what I thought we'll be talking about, I did quite a bit of work on Internet of Things and sensor networks like that, and in the process, this industrial Internet of Things, IIoT, and machine intelligence. Of course, machine intelligence is also part of this industrial Internet of Things. How the industry is being tuned and being geared up and being kind of tuning themselves for the public health management. I mean, that's very important issue now. Okay, how these things are, all these algorithms, sensors, industry, they are coming together to manage the public health during this COVID-19 period. Actually, that's what the talk is all about. And I work for School of Computer and Information Science, and almost 3 months back or 4 months back, University of Hyderabad was awarded by a government of India as an institute of eminence, and that tag actually helps us to grow and do a lot, so that we also reach out to the society. Not that it gives us some money, it also gives us some flexibility and all that. So if I look at, if I go ahead, I don't know. Yeah. So this Internet of Things, the basic thing of Internet, the foundation or the brick and mortar of the Internet of Things is sensor. So the source is Wikipedia here. I mean, it's not my definition. So the Wikipedia says that a sensor is a converter that measures a physical quantity and converts it into a signal, which can be read by any, and today mostly electronic instruments. So the electronic instrument, so what is a sensor? If it's a temperature sensor, it's a physical quantity, it's an environmental quantity. It will measure the environmental quantity, and the measurement is mostly in terms of voltage or current. So it is never in terms of a number. It's not 23 or 24 or 25 degrees centigrade. It always comes in terms of a voltage or a current, and that voltage or current need to be calibrated so that you can understand what is we can observe what is the temperature there. So, and sensor is a converter. That's the basic foundation block of a Internet of Things. So it's a sensor. So the sensor is a converter that measures the physical quantity and converts it into a signal. The signal can be in form of a voltage or a current, and which can be read by an electronic instrument. That's a fundamental thing of the whole structure. There is another definition also. A sensor is a device which responds to an input quantity. Let's say atmospheric temperature, humidity, pressure, blood pressure, your heartbeat, or whatnot. So it's an input quantity by generating a functionally related output. That's what I said. Suppose the voltage output is 2 millivolt for a temperature, corresponding temperature 20 degrees centigrade. Now the voltage output will be slightly more for 30 degrees centigrade, slightly more for 40 degrees centigrade. So based on that functionally relation, you have to find out how functionally they are related in form of the electrical, optical, or current signal. So a sensor sensitivity indicates how much the sensor output changes when the measured quantity changes. For example, if 20 degrees centigrade temperature is equivalent to 2 millivolt of output, 21 degrees centigrade, it can be 2.1 millivolt of output. If you can measure 0.1 millivolt of output, then the precision is 1 degree centigrade. If you can measure 0.01 degree millivolt, then the precision can be 0.1 centigrade, 0.1 degree centigrade. So that's important actually, because if you want sensors to be very, very precise, the least count is very low, then the cost is very high. So that's how it is actually. So sensor is the building block. So, and I don't need to talk about more. I mean, I must tell that this talk is more about, I mean, it's a techno-managerial talk. It's not about only managerial, or it's not only about technology. So it's a bit of technology and it's a bit of management. So, I mean, this is an interesting slide, which I like very much. And in many of my talks, I projected it. So there are many sensors, many systems. Now we call them as a smart versus intelligent. Smart cities are there, smart agriculture, smart water management, and there is an intelligent also. So this is a picture which I borrowed from some Facebook images, etc. And this is the quote actually. Now, if you look at the quote says that the difference between a smart man and a wise man, in fact, in this case, the smart and the intelligent, I mean, I don't want to tamper with the quote itself. The difference between a smart man and a wise man is that a smart man knows what to say and a wise man knows whether to say it or not. So in this case also, when I talk about a sensor, a smart sensor knows what to measure, but an intelligent sensor knows whether the measured quantity need to be communicated to the server, need to be a decision follows that. So an intelligent sensor, basically, when we talk about industrial IoT, the sensor has to be intelligent. Now, sensor as such is not intelligent. Sensor is just a measuring device. But to make it intelligent, it is not only measures that, but it is also able to take intelligent decisions. But it also takes decision whether this data should be transmitted to the server, to the cloud, or to the decision maker, depending upon what is the data, what is the time of observation of the data, whether it is an alarming situation or not, and so many things actually. So that's an interesting observation here. We have smart sensors, we have intelligent sensors, but the industrial IoT is mostly based on the intelligent sensors actually. So it is able to take decisions on its own. Now, if you look at, I mean, just one slide, two slides on this. An electronic sensor is a block diagram of an electronic sensor. So you have a conventional input signal, whether it's a temperature or pressure or humidity or heartbeat or body temperature or your respiratory level and all that. So there is a sensor for that. Either the sensor is developed or scientists are, I mean, the physical scientists, physics, chemistry, and all these people are working on that. So the sensor is designed. So the input signal is given to the sensor, and the sensor data is normally analog signal. Analog means voltage is analog. They don't give you a number. They don't give you 20, 23, 25, etc. They give you an analog symbol, and the measuring instrument, that's the electronic instrument, they take that data, convert it to a number, convert to a measuring, a displaying number, and then it displays actually. That's a standard electronic system. Now, what happens in a smart system? We have a sensor. The sensor data comes in terms of a voltage or current signal. Look at the. I take a just a minute. I take a larger pointer. So the input signal comes. The sensor measures the input signal, observes the input signal. It gives a voltage or current. This ADC stands for analog to digital converter. Once the analog to digital, the analog signal will be converted to the digital, and there is a computer. There is a microcontroller here, which takes some decisions, a little bit of decision, and then communicates or displays. Now, what happens in case of an, I mean, this is a simple thing. What happens in case of an intelligent sensor? The intelligent sensor, basically, if you look at this, everything is same. Only thing is that we have some intelligent algorithm sitting here. Here, look at the diagram here and look at the laser pointer here. So the microprocessor, we have a microprocessor there, we have a microcontroller, and that microcontroller plus the intelligent algorithms makes the whole sensor as an intelligent sensor. And this intelligence, actually, the machine intelligence or artificial intelligence, whatever you call it, that is embedded here. Once it is embedded here, it is able to take decision. It's able to confirm whether this data is alarming data or not, whether this data is a meaningful data or not, what needs to be done, what is the follow-up action, so on and so forth. So when you talk about this intelligent algorithm, I think people who are from computer science background or electronics background, who gives this intelligence actually? So these are the basic algorithm, these are the basic fundamental things. They give you the intelligence actually. Artificial neural network, fuzzy logic. I mean, people in economics and other things also, they work on fuzzy logic and all that. Evolution algorithms like genetic algorithms, particle swarm optimization algorithms, statistical signal processing algorithm, Bayesian, the statistician, actually, the Bayesian probability. All these things are included in this intelligent algorithm that helps this intelligent sensor to take decisions at this level itself. So we call that this is an edge node, and this edge node will be able to take decision here. Now I put one such, I mean, if you look at this word called deep learning, there is a word here, deep learning, because this is a buzzword these days that everybody is working on deep learning, and it has, I mean, I don't say that this is not good. It's a pretty good application, it's a pretty good learning algorithm. But you see, it has so much of hype now that, I mean, I heard, I mean, we have a professor who visited us, I think 6 months back, and he was saying that deep learning is such a buzzword these days that in the Bay Area, that means in the United States, unless you have in your biodata, there is a word called deep learning, they don't call you for interviews or they don't shortlist you. And he's, I mean, in a humorous way, he said that because there is an automated system to screen your biodata, you write in your biodata that you don't know deep learning. So that deep learning word is there so that your biodata will be screened in, and then you go for the interviews and prove your credentials. So that's how the things are looking at now. So, I mean, that's the introduction part of it. So how do we look at it now? The world is full of sensors, whether you like it or not. So whether it is cell phone, in our normal cell phone, there are 50 sensors actually. So in your cell phones, surveillance cameras, GPS receivers, motion and light sensors, many more. So if you don't want to see sensors, better stay at home only. I mean, you don't, I mean, in home also you have a mobile phone. I mean, you have to go to Himalayas or somewhere where sensors are not deployed. So there are sensors everywhere. Now, if you start connecting the sensors, if you connect them a network, and then we call them as a sensor network. But if this network is connected beyond, in a sensor network, there is only base station. It's like a local area network. But if you connect it to internet, then it becomes a Internet of Things. So what I'm saying that, okay, there are sensors. The sensor nodes are connected to each other. If the sensor nodes are connected to each other locally, there is a call. They are only called as a sensor network. But the sensor network is connected to the internet. That's the basic thing. If it is connected to the internet, then it becomes an Internet of Things. So Internet of Things framework for industries are known as IIoT, or Industrial Internet of Things. So Internet of Things has many verticals, like Internet of Medical Things, Internet of, there are so many things, Internet of everything and all that. Sorry. So this Internet of IIoT framework, which is designed for industries, is known as IIoT. IIoT enable industrial policies leads to Industry 4.0. So this 4.0, I mean, Industry 4.0 is basically IIoT enabled policies. They implement IIoT enabled policies. That means they buy sensors, they look at automatic robots and all these things, and slowly they build on this actually. So if you look at what is Industrial IoT or Industry 4.0 for that matter, I mean, Industry 4.0 implements Industrial IoT actually. This is how the logic is. So there are some codes somewhere. So the Industrial Internet of Things refers to the extension and use of Internet of Things in industrial sectors and applications. That's a standard definition. With a strong force, I mean, I read the second paragraph now. With a strong focus on machine-to-machine or M2M communication, data analysis, I think everybody with system specialization, business managers, etc., also read data analytics and machine learning. The IIoT enables industries and enterprises to have better efficiency in their operation. We'll see some of these things, how it looks like. The IIoT encompasses industrial applications, including robotics. That's what I was saying. Implementation, robotics, medical devices, software-defined production process. So everything will be defined by, not everything, many things will be defined by software, controlled by software. Quality control will be done by the software. The production process, the production pipeline will be controlled by software. So this is a complete architecture through which the industries will be controlled. Wherever possible, they will use robots. Wherever possible, they will use sensors, so on and so forth. So in the context of Industry 4.0, the IIoT is an integral to how cyber physical system. I think I can skip this one, but cyber physical system is that you have a cyber means internet based software and all these things. Physical is your machine, your manufacturing. So this two has to, the marriage has to happen in between these two, and then they help us in increasing the productivity. And so this is with the, you can do it with the help of sensors, but sensors are nothing but the data collector machines actually. They keep on collecting data, and the data analytics, the machine intelligence, the intelligent algorithms, etc., has to put on that so that it becomes a completely industrial IoT framework. So what are the enabling technologies? As I promised you, this will be a slightly techno-managerial talk kind of a thing. So the basic enabling technologies are these 5 are the basic enabling technologies called, one is called cloud computing. So I don't need to define what is a cloud computing, etc., because almost everybody knows what is a cloud computing. So with cloud computing, IT services and resources can be uploaded to and retrieved from the internet. So somewhere the server, somewhere the computing infrastructure, somewhere the storage, everything can be outsourced. You don't have to host everything. So it is in the cloud, and you put everything, whatever is required, you borrow it from them and then configure it and use it. Edge computing, in fact, whatever I have discussed so far is called an edge computing. What's an edge computing? You have a small controller, you have sensors, you have controllers, you have some algorithms sitting on it, and at the edge node, that means at the remote place, wherever the sensor is, with some kind of intelligence, you take a decision, and that decision, that edge computing will be taking a decision. So this decision is basically a distributed computing paradigm, which brings computer data storage closer to the location where it is needed. So suppose I think Professor Atmanan, he has introduced me that I did some project with IIT Delhi and everything. The project what we are trying to do is that we are monitoring the water quality in the river Yamuna. So you cannot monitor sitting at the lab or sitting at the server. So some decision has to be taken. So we took the sensor nodes nearer to the river, and that adds. So the idea is that the data storage, the computer data storage, the intelligence has to run closer to the location where it is required. So industrial internet is also actually edge plus cloud architecture. What I mean by edge plus cloud architecture, some decisions are taken at the remote location, some decisions are taken at the central location, which is nothing but a cloud. Data analytics, I don't want to talk about data, but then big data is also a big talk about it in these days. So data analytics, I think everybody knows that. I don't want to give a talk on that. Artificial intelligence and machine learning. Artificial intelligence is a framework within computer science so that the intelligent machines are created that work and react like humans. I repeat, like humans, that can never be humans. Machine learning is a core part of AI. It's a part of AI, allowing a software to more accurately predict outcomes without explicitly being programmed. I'll show it in the next slide. So what is the generic IoT architecture or industrial IoT architecture? I don't want to talk more about the down layers, because if you look at this layer, there is a sensor and actuator level. So sensors are there at the bottom level. They collect the data. Once they collect the data through the gateways and networks, they send the data. Then there is a service management control, but we are more interested in the top layer. That is how do we develop applications based on the data that is coming. A huge amount of data, terabytes of data, petabytes of data, zettabytes of data are coming up. What do you do with that? How do you organize them? How to get meaningful information about them? How do you use this data to serve this society? Things like that. So the same thing, I think, if you look at the sensors at this layer, we get some sensors, they are networked together and they get the data. There are some towers, there is a cloud space here. But most importantly, this is the space where the techno managers are working. So they talk about environmental problem, they talk about energy problem, they talk about healthcare problem, transportation problem, supply chain problem, surveillance problem, people tracking. I mean, people tracking is not considered as a good thing, but then people tracking is required for COVID-19 situation. So all these things are being used for in the IoT architecture. I think I can skip this slide because this is same thing. Okay. Now machine learning, because IoT and the machine learning has to be there so that we can think of some of the applications, or in the subsequently we'll look at some of the applications. What happens in a machine learning is that how it is defined. Machine learning is a branch of artificial intelligence. It's an intelligent algorithm kind of a thing that concerns the construction and study of systems that can learn from data. I repeat here, the system which can learn from the data. You give them the data and the system will learn from the data. So there are so many things. For example, there are many case studies in management and all these things where people say that, oh, we didn't know this. We learned it the way you behave it actually. For example, there is a case study, management people might know better. There is a case study where say that the petrol, the gas stations in the United States, they call it a gas station. In India, we call them as petrol filling stations. Now, in the petrol filling station, when I come back from the office, I go to the petrol filling station, I buy my routine medicines or monthly medicines, I buy my routine grocery, I do something. So they thought that when you stop for filling up the petrol, you can also buy certain stuffs. And that was a normal, that they discovered, the machine learning algorithm discovered from the data that people, when they come, they fill the gas, then they go and buy medicine, and they followed their credit card transaction, etc. And that information led to having shops, having supermarkets, having small shops near the petrol, the gas station itself. So that is, there are so many examples that you learn from the data. In fact, these are few quotes about machine learning because, as a business student, you should be interested in knowing it. A breakthrough in machine learning would be worth 10 Microsofts. That's what the Bill Gates says. Bill Gates, the chairman of Microsoft, says that any breakthrough in machine learning, in fact, it is so huge, so powerful, so impactful. The impact is so huge that any breakthrough in machine learning will be worth 10 Microsoft companies, right? That's what the Bill Gates says. Machine learning is the next internet. The internet has changed the diaspora completely. They changed the whole domain of knowledge completely. The director of DARPA is the organization which started this internet networking thing. So Tony Tether said that machine learning is the next internet actually. Now machine learning is the hot new thing. That's what the president of Stanford says. Machine learning is going to result in real revolution. That's what the CTO of Sun Microsystems says, Papadopoulos. Machine learning is today's disruption. We talk about disruptive technology, etc. And the CEO of Yahoo says that machine learning is today's disruption. So what is the basic machine learning actually? The basic machine learning is about predicting the future based on the past. So you have the data. How do I have the data? Because I have the data means it is the past. I have already observed the data. Now based on the data, how do we predict what is going to happen, or how the behavior is going to change? So that is what the basic machine learning is. Now, if you look at the diagram here, the past is the training data. Whatever data you get, you train the system, you understand. For example, you take your 2-year-old kid or 1-year-old kid and show them a cat and then keep on telling them this is a cat, this is a cat, this is a cat. So you take 10 varieties of cat, 20 varieties of cat, 30 varieties, different types of cats, show them and say that this is a cat. Now you take a new cat, it will the child will learn that it is a cat, and the new cat, it will say, oh, this is also a cat. It may not be the same cat. It may be a little bigger, a little fatter, a little smaller, little change in the color, but still the child learns that this is a cat. That's exactly happening in the machine learning. We train it with so much of data, but when you show a new data, new pattern, this training also helps the machine learning tells us that this is going to happen with this type of data pattern. I give a, okay, the example can be skipped here also. We'll come back to that example when we discuss about certain other example. So what happens actually, the past is your data, with the data you train it. So sorry, with the data you train it, and the machine will learn. There are so many learning algorithms. I mean, people from computer science background, electrical background also will know. And the learning will prepare a model actually. And that's what all we do actually. We either prepare manually or the modeling can be done by the system itself. Now this, once the model is ready, now take the model here. This is the same model is ported to this place. And the new data when you get in future, push that data into the model and the model will predict what is going to happen with this kind of behavior. Now, what is the basic difference between traditional programming and machine learning programming? I mean, you don't do programming in machine learning. So there are many tools available, and computer science people actually learn how to develop tools, but the techno managers, etc., they don't need to develop the algorithm. Now, what happens is a normal thing that you give a data, you write a program, for example, Excel sheet or a basic or C programming or whatever programming, you write a program, you give the data, the computer will give you an output. And this output is always true for the same data, because same data, same program, output will be always same. Now, what happens in a machine learning is very interesting actually. You look at this, you have the data. So my data is the image of a cat, the image of a football, the image of a volleyball, the image of a celebrity. Now, the output is that you train the system, you tell the system that this is an image of a cat, this is the image of a football, this is the image of a volleyball. The computer system will create a model. So using the computer model, the machine learning models, a program will be created. Now look at this, the program is an input here in the top, the program becomes the output in the bottom. So in a machine learning scenario, you give the data, you give the level, you give the output. Now, continuously give the data and output to the system, and the system will learn to create a program for you. So let's say face recognition. You give the face for 100,000, 100 million faces, and then ask the system to learn. Now, you don't know how the system is learning actually. You are giving a model, the system will learn it because you are continuously telling the system that you are right, you are right, you are wrong, you are right, you are wrong. And then the system learns that, oh, this is right. It adjusts its weights and learns it. So this is how the learning, learning is any process by which the system improves the performance from experience. I mean, that's what Howard Simon says, that learning, how do you learn? So when I say machine learning, my machine learning algorithms are not fixed. That's very important. I want to highlight again. My learning algorithms will not give the same output every time you run this. So the learning algorithms keeps on improving itself by virtue of its experience. So today, if I take 100 images and train the system, it gives me an accuracy of 90%. Now, when I take 1,000 images, because with time I learn it, I get more data. Now, I tell the system, there is a feedback loop. I tell the system that, no, you are wrong. Then the system tries to improve itself. So the system here, the machine learning algorithm is designed in such a way that it learns from its mistake. It learns from its successes. So when it is a success, the system reinforces the learning. That's what we call as a reinforcement learning. And if the output is a failure or a false, then the system readjusts its learning and tries to correct itself. So that's what is very interesting paradigm here. So what do we do here? There are different types of learning. I think we may skip this slide also, but just for a quick introduction, supervised learning is what? You take the image and you also take the output. So you supervise it. The system is trying to learn, and you supervise the system to learn it, like you teach a baby. Like unsupervised learning, so it is not that the baby learns whatever you teach it. They learn certain things on their own also. So that means you only give the data, don't give them desired output. The system will find out some interesting outputs from the data. And I tell you what is this actually. I give you this example actually. At that time, I was not in University of Hyderabad. Some 30 years back, 1986 to 90 or something. So we have an artificial intelligence lab set up way back in 1982. So when people were not knowing what is artificial intelligence, University of Hyderabad had a center here. Now, what they did, they took some data about the university entrance examinations, and they tried to learn from the data. So they went for this unsupervised learning, and the training data, they just allowed the data to be trained, and they found out some interesting patterns. I tell you what is the interesting pattern actually. The interesting pattern was that they found that any student who is a girl, a female, a girl took admission into the computer science course and from Orissa came and turned out to be a married lady. Now, what is that they found? They found that any girl student who took admission in Masters in Computer Application or in our computer science department, and she is from a neighboring state called Orissa, then they found that in almost all cases they are ladies. They are married ladies. Now, why it is so? Because Odisha as such is not very progressive, and I think unless the girl doesn't come out of the house unless the husband or the in-laws family allows them to come. Now that information prompted University of Hyderabad to come out with married hostels and all these things, right? So that was kind of an unsupervised learning. We never knew that, but the unsupervised learning churned the data, came out with some patterns, and that pattern was very interesting pattern. And in many cases, they prompt the administrators, they prompt the managers to take some decisions. Semi-supervised learning is a hybrid of both. So part of the data is supervised, part of the data is not leveled, so you take a decision. Reinforcement learning, I just gave an example where I say that, say for example, I'm playing chess, right? Your one move will not decide whether it is a good move or a bad move. A set of moves will decide whether it's a good move or bad move. Suppose you are playing badminton or you are playing football. You cannot exactly say that because of this, I lost the game or something like that. A set of moves will decide whether it is good or not. So for example, when you are giving data, one particular record you cannot level. For example, when I'm talking about water quality, I cannot say that immediately a set of sensors, this data, it's a bad water. I continuously monitor it for some 5 minutes or 10 minutes. Then I say that this is good or bad. Now, when I have within this 10 minutes, I get some 100 records actually, 100 observations. Then after 100 observations, I'm able to know that, oh, this is a bad move. So what I do, I go back, I reinforce my learning that, look, all these 100 observations are bad, or all the 100 observations are good. So this is called reinforcement learning. When you know that you are good, you reinforce that value. If you know that you are bad, you go back and change your system, penalize the system so that the bad things will not happen again. Okay. Now let me come to the interesting part of it. So this is basically an introduction about what we are talking about, what is industrial IoT, what is machine learning, what is cloud computing, what is artificial intelligence, and how things can be put together to solve certain problems. So the problem at hand now is that the COVID problem. So it's a pandemic problem statement. So you all know that on March 11th, 2020, the World Health Organization, who has marked this outbreak of novel coronavirus as a pandemic. Now, what the management part of it, look at the right side of it. The right side says that the management part of, there are many things, but I just listed the 10 points actually, and we'll try to touch upon each point and what the industry is doing for all these things. And so routinely and thoroughly handlers, I don't have to repeat anything. Everybody knows about it actually. I may not be knowing that much actually. Social distancing. I never heard this term, but at this age, I heard this term called social distancing. We know about physical distancing. We know about social bonding and all these things, but this is a new term that has come out called social distancing. Face protection. People say that you have to use mask and everything. We'll talk about that actually. Avoid face touch. They always say that if you don't touch your face, you are not going to be infected actually. So in the public health management, we try to tell people that you avoid face touch, you protect your face, you maintain social distancing, you routinely and thoroughly hand wash it for 20 seconds or so. You try to use your devices, use lift, use everything with a contactless control. Don't touch anything, touchless, contactless control. Self-isolation is a new term that has come up. You isolate yourself. Contact tracing, again, you know all these things, contact tracing, home quarantine. I mean, so many terms has come up and we all know about these things. So I don't want to spend more time on this, but we'll talk about what industry, what the IoT, what the sensors, what the machine learning is trying to, how industry is using all these things to help these things actually. So screening and monitoring, mass screening and testing. So all these things all these terms are not kind of everybody knows it. So industry need to ready and address all these issues actually. So this is a 10-point agenda which is required for mass with public health monitoring during COVID-19. And the rest of the talk is mostly about how machine learning, how your industries are gearing up themselves and are doing to address these issues. So IoT-based sensor system for health monitoring, look at the diagram. So you have health data monitoring. We need to monitor the health data. Then we have wireless communication, Bluetooth and Wi-Fi and all these things. Through that, you send the data or you take the decisions at the node itself. So the data aggregation and analysis are done, and then some follow-up action there. So this is the flow chart of how the IoT-based sensor system for health monitoring is happening. So this if you look at this is the IoT for COVID-19 module structure. We talk about medical IoT this year. We talk about social distancing. We talk about contactless activity. We talk about cost-efficient solutions. We talk about health screening. We talk about contact tracing. And all these things, we need to look at how this IoT for COVID-19 is going to handle all these things. Now look at this actually. I'll just quickly talk about issues number one. Now this is a small sensor-based hand sanitization system. It's a small video. Just a minute. I don't know how to play it. Give me some time. Yeah. Now look at this. So there is a company called Pumpix. So what they do, I mean, this is whenever they find it. So okay, you read. Look at this. I don't have to tell anything. No, I stop here because you just look at this one. Whenever it looks at an object and you are going to touch that, you don't have to press actually. It detects that there is an object at a distance of some 6 centimeter or 4 centimeter or 5 centimeter, and immediately it sanitizes or it sprays that sanitizer into that particular object and it gets disinfected. So before you touch the handle, before you touch the car door, before you touch any lift button, etc., it detects that your hand is going closer to a particular object and the sanitizer is sprayed so that the object gets disinfected. Now what is this actually? What is that? I tell you what is the technology here. The technology here is that you have a sensor, an ultrasonic sensor. What is the ultrasonic sensor does? It sends a sound wave. The sound wave travels. Whenever it gets into an object, it comes back. So you take the round trip time and then you measure what is the distance. The moment the distance is around, say, let's say 4 centimeter or something, the controller is activated and there is a spray. The spray is going on. And if you want at a particular time that you want it to be manually done, you press a button, it will be manually sanitized that actually. So that's how yeah, this is how the design is there. So the design is that you can take it, you can refill it, you wear it. So it goes for yeah. So look at this. Actually, here because the object is not closer, the lady pressed that one actually. Yeah. So this is something which I borrowed from Facebook also. And the company, there is a company which is coming up this. Now look at this. If you look at the technology wise, it's not something quite disruptive actually. We had ultrasonic sensors, we had controllers, we had sanitizers, everything is there, but everything is packaged together. And this is one of the hot thing, that an impressive thing that's going on now. Now, if you look at there are certain other things. I mean, this is one aspect. I think if you look at the 10-point agenda, the first point is that how do we go for sanitation, etc. So there is a company, there is a model which works. Now look at this. This is another part of this design approach for avoiding face touch. Now we all know that by this time that during the COVID-19 and for the public healthcare, government is continuously alerting us, educating us to avoid face. So, and you know, a human being by nature is we touch our face in a semi-conscious mode and all that, and we cannot avoid it actually. So that happens every time actually. So what do you do? These are three technologies actually. Four technologies actually I will discuss. So at MIT lab, MIT, that Massachusetts Institute of Technology in United States, and there is a company called Emerald also. So the Emerald Emerald INC took that idea from the MIT, and then they started a company there also. Now look at this. These are the three things actually. If you look at the image here on the left side where it is written saving face, and I will come back to that. So this one in the middle actually you see some of the controllers, some neural network architecture, some sensors, etc. This is what we have done. So this talk is basically a mixture of what others are doing, what we are doing, and where are we now actually, and what we all can do together also. So let's talk about, there are three technologies actually. One is called ultrasonic inspired. So ultrasonic inspired, I will talk about that. I also spoke just now that ultrasonic is a sensor which sends us ultrasonic wave, a sound wave, which travels at a speed of sound. And then whenever there is an object, there is an obstacle, it travels back. So you measure the round trip time, and that round trip time is basically you calculate what is the distance. So the distance is, let's say, 331 meters per second is this speed, and your electronic can measure that what is this round trip time, and accordingly you can decide at what distance your obstacle is there. So based on that, they found that you want to avoid the phase touch. There is a magnetic sense, or maybe I can come here. Next slide, we can go. Now look at this. What is you look at the top diagram there. Now you see that there is a earbud. I mean the kids, everybody uses that actually. So what they do, there is a ultrasonic sensor. They put an ultrasonic sensor there in the earphone, and the earphone, it continuously sends the ultrasonic sensor. And whenever your hand comes nearer to the mouth, see that actually. So whenever your hand comes nearer to the mouth, so let's say it detects around say 5 centimeter or 8 centimeter, etc. The moment the distance is closer, then it is a vibrator actually. So basically it vibrates actually. So if you look at the left side, using a sonar inspired, sonar means ultrasonic sensor approach to measure the distance between the hands and the face. How it works? The earbud transmits an ultrasound signal. Then you can find out whether it is what is the distance actually. Now there is a vibrator actually. Now once the vibrator is there, so it will vibrate it. Now somebody can ask that no, sometimes I want to touch my face because I feel an irritation. Okay, you sanitize your sanitize your hand and then touch your face. The vibrator is only a signal that you are going to touch your face, so that you are not doing it, I mean, unknowingly. So it cost around nothing but more than it cost around 400 rupees. The bill of material is around 400 rupees. The company name is called Emerald INC. Now this is a screenshot of that. Now look at the other story actually. The other story is called this magnetic sense, MagSense, or magnetic flux based sensor actually. Now what is this magnetic sensor does? If you look at this part, the figure part, there is a pendant kind of a thing. There is a necklace, there is a pendant kind of a thing. And in the finger, there is a ring kind of thing. The ring is nothing but a magnet actually. So you can take a small magnet in your gold finger or some gold ring or something. You can put that magnet there. And what is that pendant actually in that necklace actually? It's a magnetic flux sensor. We call this a magnetometer or magnetic flux sensor. Now what it does, so whenever there is a magnetic flux sensor, when the magnet comes closer to your neck, right, then there is a flux. There is a change in the flux. That flux, so now you see where is machine learning here? Now you see, first I train the system. There is a controller there. I train the system that look, there is no magnet, there is no magnet, there is no magnet. Now when the magnet comes closer, let's say 10 centimeter closer, there is a disturbance in the flux, and I measure the flux and I say, okay, now the distance is 10 centimeter. I take my hand little closer and I say that, look, at this point of time, the distance is only 5 centimeter. So I train that with this much of magnetic flux change, this is the distance that is measured actually. So once you implement this, right, once it is done, the training is done, every time the user will wear the pendant, will wear a gold ring with a magnet there or whatever it is, some kind of a magnetic ring. And then whenever the hand comes closer, it will detect that the distance is only 5 centimeter because it's already trained. And then it will, there is a vibration actually. So in your finger, you get a vibration. So if you look at this, that's the same thing I'm telling here. A device has been developed that vibrates when the hand and face get too close. The device consisting of a transmitter ring or a bracelet, whatever it is fitted with a tiny magnet which creates a magnetic flux. The receiving sensor, we call it a magnetometer, along with a controller embedded with the necessary code is developed. So what is that necessary code? The training code is already developed and it is there in the necklace. It's a wearable device. So whenever the hand comes closer to the face, the magnetometer detects the change in the flux, and then there is an alarm of vibration. So this is how the technology works here, and the same company is also doing that. This is the third technology which not them, but some other people have proposed, the smartwatch and Bluetooth signal strength. What is a smartwatch? Everybody uses a smartwatch, and everybody knows what is a Bluetooth signal actually. So what happens actually? So what is a signal? You know, any wireless signal, there is a concept called RSSI. If you look at this line, the first paragraph, the received signal strength indicator. That's also there in our mobile phones also. If you are not accessible to the tower, your number of bars are very less actually. So signal strength determines how far you are from the transmitter. So if the signal strength is less, that means the distance is more. If the signal strength is more, then the distance is less. So depending on the signal strength. So what do? We define there is a smartwatch, and so the smartwatch, and there is your earbud. So in your earbud, Bluetooth is anyway there. Your smartwatch is also sending the Bluetooth signal. So when you raise your hand, the smartwatch Bluetooth device and your earbud Bluetooth device, they detect that what is the signal strength, and they train the signal strength in such a way that they can measure that how far is your hand from your face. So this model is also used, but this is not very. So you know why this is popular or why this model is proposed. You don't require any separate sensor. For example, for MagSense, you require a magnetometer. For earbud, you require an ultrasonic sensor. But smartwatch and Bluetooth, everybody has a smartwatch and has a Bluetooth speaker, Bluetooth earbud. So this works with that, but it's not very accurate actually. It's not very accurate. So that is why it is not very popular also, because it's not very accurate. We in our lab also, and in association with a company called FogR, it's a company. If you look at the last line, the red line, it's a FogR Technologies Private Limited. It's in Hyderabad only. So what we did, we also did the same thing, almost similar thing. So what we did, we took a controller. This is the controller. If you look at the right side black module, this is the controller. So in this controller, we put the sensors called accelerometer. What is an accelerometer? Accelerometer is a sensor which measures the acceleration in the x-axis, y-axis, and z-axis. Gyroscope is a sensor which measures the temperature. Sorry, not temperature. Sorry. Gyroscope measures the change in the angle, rotation. X-axis rotation, y-axis rotation, and z-axis rotation. So theta x, theta y, theta z. Accelerometer is accelerometer x, accelerometer y, accelerometer z. By taking these 6 parameters, what we did, suppose you move your hand, right? You raise your hand. When you raise your hand, the accelerometer values will change. And when you want to touch your face, normally you rotate your hand, your palm comes up, right? So normally, I'm saying it normally. So the palm comes up. So there is a rotation and there is a change in the gesture. This we use the machine learning algorithm to train that you raise your hand and then rotate your palm, probably you are going to touch your face. And what is big deal here? I mean, in fact, if you are wrong in predicting, a small vibration will be there, but you can ignore that vibration. But it will not allow you to touch your face without the vibration. That's the core of thing. The below, there are some small circles. This is basically a neural network. Machine learning is based on a neural network model here. Now, if you look at, there is a interesting work actually. It's called, Bikram, how much time I have? I need around 15-20 minutes. Is it okay?
Yes, sir. Yes, sir.
Is it okay? I have 15-20 minutes, right?
Yes, sir.
Okay. So there is a concept called Q band. The Q band is actually quarantine band. You might have noticed that in the newspaper, etc., there are many people who are under quarantine. They are actually not following quarantine principles or quarantine protocol. Actually, they are supposed to be inside a home. They come out. They are supposed to be. They are not supposed to go outside the particular area, but they go out for something. Now, what they go, I mean, in some cases, it is practiced in Italy and in China also, but unfortunately not in India. But very recently, last week only, if you look at the last line, that green line, you see that last week DRDO came out with a similar device. Now, what is this device is actually, they designed a small band, a kind of a wristband or a wristband. Inside the wristband, there is a small processor and there is a small GPS module and there is a small communication module and everything. I will show you the picture also. Now, what they do, so suppose you get down from the train or get down from the flight and they say that, look, you are supposed to be quarantined at home. They ask you where is your home, etc. So they immediately code that, they give that location of the home and they tie that particular band around your wrist. Now, once the band is there, Now, once the band is there, I repeat, once the band is there, you cannot take out the band. Any tampering with the band, it will give a notice to the central server that such band ID, such and such band ID is being tampered. So the police or the health officers or the administrator will come to your home and say that, look, and every person under quarantine is identified with a band. So what is the process? The process is that a person need to be quarantined. First, what they do, they give you a band. What is the band? The band consisting of a small controller, a small GPS location, a small Wi-Fi module. So that's what the IoT part of it. And it is, once it is fixed, once it is given as a band, then you cannot tamper it. If you tamper it, you open it, try to open it, etc. So that vibration, etc. is trained. Actually, so what they did, they allowed some people to go with the band. And once the band is tempered, they say that they trained it that this is going to be tempered. This is a tempered band, and a message goes there. So what happens here? So if you look at the diagram here on the right side, there is a patient module. The patient is so ESP32. If you look at the sensing node, there is a ESP32. ESP32 is the controller. And then the band state. What is the band state? If it is tempered or not tempered, if you are trying to open it up or you are trying to take it out, etc. So there is an Android phone, etc. there. So the authorities web interface, look at the police or the web authority actually, all the data is continuously going there. So what it happens, you look at the left-hand side actually, to monitor the people in quarantine. This is the device to monitor the people in quarantine. There is an industry for that actually to do this. A device permanently fixed onto the body. You cannot take out this device for 14 days because you are supposed to be there on quarantine for 14 days. An alert is generated in case there is an attempt to tamper the device. Now, how do you classify that it's an attempt to tamper the device? The machine learning algorithm has already been developed, trained, and then it is embedded into your device. It communicates with the central server periodically, every 10 minutes or 15 minutes or 20 minutes. It tells the server that this guy is at this location, or following the change of location. If you change your location, immediately it prompts that this guy is not in quarantine, it's moving out. Now, the whole thing is designed, experimented. The industry, there is an industry which worked out, and they found that the battery life has to be at least for 14 days because you cannot change battery, etc. So they put your band, then they put a kind of a wrapper, and then they leave you. So for 14 days, the battery will last, everything is there. The last one, the geofencing facility. What is geofencing facility? If you move out of, suppose they say that your location is this, and the area is 50 meters. So you are not allowed to go beyond the 50 meters. The moment you step out of 51 meters, there is a message that goes to the health administrator. And all these things are machine learning, the training algorithms are done, and everything has been done. So this quarantine band is very popular actually, and there are some people who are doing it. And this is the complete workflow. I can skip this slide. Now look at this actually. So you look at the diagram at the top left corner actually. So there is a band. The band is 6 centimeters. It's around the wrist, and there is a compact battery inside that. If you are not happy, some people may be having problem with the hand, etc. It can be also, it's a wearable device. You can also wear it in the legs and everything. There is a battery pack, there is a pause, there is everything actually. You can even wash it, you can take bath and everything. But only thing is that you cannot take it out. Once you try to take it out, there is an alarm, there is a message that goes on. Now, this is a geofence breach actually. So if you look at the Google map, actually, you are supposed to be here in the red position. If you move out, then the GPS data is fetched from the wearable, and then immediately it says that you are moving out. There is an alarm. So the alarm, when the alarm will buzz, people around you will know that okay, you are supposed to be under quarantine and you are moving out. So this is one sort of story. Now look at social distancing. People are talking about social distancing. You should maintain at least 2-meter distances. There are many people use circles. You should stand in one circle. The other fellow should stand in the other circle. But what this IoT sensors, etc. are doing, there are three approaches actually. One is called Bluetooth-based approach. What is Bluetooth-based approach? There is a Bluetooth device which sends the signal, and there is another Bluetooth device which receives the signal. Now, as I told you, the received signal strength measurement will train the system how far or how close these two Bluetooth devices are. Suppose one Bluetooth device sends a signal, the another Bluetooth device will receive a signal. The difference in the strength of the received signal will find out at what distance the transmitter Bluetooth is there. So that's the key actually. So what do you do actually? Even the Arogya Setu app, that's also does with the same principle actually. It tries to find out your contact. If it stores the Bluetooth information, the received Bluetooth information about the other transmitters, so that if you are infected, immediately they find out that who are the other people who has come in contact with you. Now, Bluetooth is a good. So in Bluetooth, actually, it is 360 degree. So people who are at a distance of 2 meters, that's what the government norm says, that are within the distance of 2 meters in 360 degree around you can find out that, okay, that record can be there. GPS module is also good. People use GPS, but GPS is not accurate. And there is a problem with vertical distance. For example, I am staying in 7th floor and my neighbor is staying in the 8th floor, but the GPS location will be same. But we are in the 2 different floors. We have not come in touch with each other. But GPS doesn't understand that. Ultrasonic based, what is ultrasonic based? I think I have been repeatedly telling because we did some work on that. The ultrasonic, that it sends a sound wave. It gets if it gets an obstacle, it reflects back. But only problem is that it's very, very accurate. It's very accurate. In fact, I can find out that you are 2.53 centimeters away from me. But the only problem is that it is directional. It cannot measure you in the 360 degree. So if you look at the technology, so these are the technology and these are the devices. If you look at the devices, smartwatch, smartphone, dedicated device, people are using dedicated device also for maintaining social distance, etc. Mass monitoring. I'll show you, I think, a small video in the next slide. Yeah. This is a video, I think some of you might have seen it. This is a video of a technology that is deployed. If you look at this, somewhere you look at epitourism. Somewhere it is written on the top, actually, epitourism. So this is a video of Tirupati temple, which is a famous temple in South India. So the epitourism people have done it. So what they did, they took 2 Bluetooth modules. So one Bluetooth, so a device has a Bluetooth module. So everybody, there is a Bluetooth module and there is a light. There is a LED bulb. And what the LED bulb does, so the Bluetooth module, and if there is another Bluetooth module within 2 meters, then the LED becomes red. The red light glows. If it is not within the 2 meter radius, then the green light glows. Now, if you look at this actually. See, people are moving actually. People are moving, and whenever they are, there is nobody around, no other person around 2 meter radius, the bulb is green. But if there is a person within 2 meter radius, then the bulb becomes red. Look at this. Look at this. There is yeah, good. See, there are a couple of people, 4 people standing together, and it's all red. There is a person walking in. There is a green. Yeah. See how the green changes to red. So it's all very interesting actually. So this is how it works actually. There is a sorry. Yeah, I want to stop here also. Now look at this actually. Now you go to any temple, you normally ring the bell. I mean, you hit the bottom and then the bell rings actually. Now what people say that you should not touch it actually because it has to be touchless, contactless, and all these things. Now, if you look at there is a device here actually. It's an artificial intelligence enabled camera. Now you move your hand actually. So you will not actually touch the bell. You will only move the hand. The camera detects that you are trying to ring the bell, and the bell automatically rings. Right. So in any temple, it's in Somnath temple actually. So in any temple actually, now they have set up a device here. I mean, a company has come up to address this issue, and it's not a big deal actually. So what is that actually? I took an image. I took a camera. Now in the camera, the videos always continuously looks at it. It absorbs the video frames. You move your hand. It detects that you are moving the hand in a way that you are trying to touch the bell or you are trying to ring the bell, and then it detects that gesture, and then the bell rings. So you feel that you are not touching the bell, but still the bell rings. So your religious sentiment is addressed, and the whole work is going on. Yeah. Yeah, this is the camera and all these things. Yeah. So if you look at this, this is how the social distancing using Bluetooth technology and using camera, hand gesture, etc. people have done it actually. Now there is there are some work. It's an interesting paper actually. It has come out in very high impact factor. I just took this one, and it is a very interesting way of implementing machine learning, sensors, IoT, and everything. Now look at this, what it talks about actually. You look at the top part of it, the first green line. Now say what is that people are normally saying that if you feel some kind of a symptom, and you should not be. So look at this actually in the top green line. I'll tell you what is that. There is a fingerprint scanner on almost every smartphone actually, right? You put your finger on the fingerprint scanner. Now the fingerprint also can detect the temperature. Now, how it is possible? Because there is a temperature sensor there. Now somebody can say that, look, my finger temperature is not my body temperature, but they map it, they correlate it, they compensate it, that how much, if your fingerprint temperature is 25 degrees centigrade, your actual body temperature is 27 degrees centigrade. So that mapping has been done, and your fingerprint scanner on the mobile phone will give you what is your temperature. So your body temperature can be continuously monitored. Your cough voice, suppose you are talking, they say that you cough, and that mic is on, so your cough voice can be, samples can be taken. They ask you to, they tell you that 30 seconds ka sit up karo. So you sit down, stand up, sit down, stand up. So within 30 seconds, you have to do 10 sit-ups. And if you're not, and all these things can be monitored by the smartphone, not through video. So the smartphone has accelerometer sensors. The smartphone has gyroscope sensors. So when you sit down, the smartphone detects that you have sit down. When you stand up, the smartphone detects that you have stand up. It counts. Then it asks you to do a 30-second sit-up. It asks you to do a coughing in the microphone. It takes that data. It takes your temperature. And when you do a 30-second sit-up, actually, after that also you have to cough. That sensation also coming up. There is a human tracking. Whether how do you move and other things. Now, if you have some CT scan of your things, you can also upload that. But look at this. Now you come down, go to the blue part of it. What is your cough level? What is your fatigue level? Fatigue level means after doing your 30 seconds of sit-ups, what is your nausea level? Are you feeling tired or anything? That everything is being determined. And look at the algorithms here, that pink color kind of a thing. So that pink color is algorithm. So all of my machine learning algorithms. How do I do it actually? I know I train my system I train my sensor net IoT device to count how many times I'm doing setup. I train my system to machine learning to classify whether this cough is a dry cough or a cold cough. I train everything actually. After that, there is a machine learning algorithm. RNN stands for recurrent neural network. CNN stands for convolutional neural network. The paper talks about that. And for COVID initial thing, and there are two options actually, two classes actually, whether you are positive or negative. Now the positive or negative, they come out with a confidence actually. It's not that you are always positive. They say you are positive with 60% confidence. You are positive with 70% confidence. You are negative with 90% confidence. So that confidence level is also attached to that. So they have used Bayesian probability. They have used all condition probability. They have used machine learning algorithm. So everything has been done. They have taken the data set and do it. Now, what is the advantage of this? You have a smartphone. You do all these things. You download that application. You download that algorithm. Of course, it's not freely downloadable now. And then you do exercises. You do everything at home and try to monitor yourself. That's the model here. Contact tracing. I think this is a slide which talks about how people do contact tracing, but I can move it actually. Now look at this. This is the same thing actually. The contact tracing also when people are there at home. Now you look at the diagram actually in the bottom actually here. Now somebody is sitting, your temperature is being monitored, your cough is being monitored, your heartbeat is being monitored, your movements, it's a smartwatch, your movements are being monitored. So when everything is monitored, suppose you trace the contact, who is coming, who is going, and everything is being monitored here. Now the machine learning algorithm here is that your cough, your temperature, your heartbeat, or your respiratory level, how many times you're beating, etc. Everything is monitored. And now they are advised that the system is in place. There are companies can come in. There are some companies in China. There are some companies in Japan, but we don't have a company like that. So if you have a company like that, which can come with a device, set it up at your home, and then you are being monitored from your home only. So that's one model. You can look at this. Connected thermometers. This is very interesting actually. There is a company in California, United States called Vivalink. So they came out with, it's not a very big deal, but that's how it is working. So they came out with a temperature sensor as a temperature kind of a small device. They call it a connected thermometer. Why do they call it a connected thermometer? If you look at the right side of the image, there is a thermometer, there is a kind of a mercury, and you see that there are three lines here. These three lines actually, they're actually pointing to there is a wireless communication. So what it does actually, whenever there is a thermometer, this connected thermometer is that whenever there is a temperature is measured, this temperature is uploaded to a server, right? So now the government has a data, or the health administrators have data that how the temperature, what is the temperature across the community actually, across a particular city, how it is being monitored. So if you look at the left-hand side, let us read the text part of it. The connected thermometers are being used by hospitals to screen the patients and staff. Continuous real-time monitoring of any changes in body temperature is going to the server. This uses the IoT access controller to receive the real-time patient data. There is a company called Kinsa Health. Kinsa Health, what it does, the connected thermometer is a company, is marketed by the company called Vivalink. And Kinsa Health is a company which collects the data and does the data analysis actually. So Kinsa Health gathered data from over 1 million connected thermometers to show a temperature map of the region. I mean, you might be knowing about the heat maps and all that, right? So the connected thermometers in United States, I mean, in most of the cities actually, now they are finding that in whatever communities, there is a red zone, green zone, pink zone, yellow zone, etc. Thus they see that how the temperatures are being monitored actually. They don't point out at individuals, but they point out that in which area the temperatures, the average temperatures are rising. There is this is I think I have already talked about that, but this is a company called IIT Instituto Italiano. I mean, this is basically an Italian company. So researchers at IIT Instituto Italiano di Tecnologia have designed this particular device. But what is this device actually? This is a small device which has a Bluetooth there and which has a temperature monitoring there actually. So it measures the body temperature and also measures the nearby other devices. How it measures the other nearby devices? It has a Bluetooth, so it always finds out the other Bluetooth devices. And whenever there's a Bluetooth devices, then it measures the signal strength, how close they are. And after that, all this story can be told. So when two smart bands are in proximity, they vibrate and alert signal that helps the people to respect the social distancing. The frequency, I mean, I don't want to talk about that. So they use 2.45 gigahertz frequency, which is same as Bluetooth. And there is a company called CloudMinds. So all these things, so people are using as a bracelet or a ring to sync with an AI platform called CloudMinds. So CloudMinds is a company which collects all the data, does all the machine learning algorithm, data analysis, etc., to find out how it is going on actually. IoT button, I mean, this is a very simple logic actually. What is an IoT button actually? It's a button that they are there in the hospitals and all these things. It doesn't have anything. It doesn't do anything. So the company called Vision State, the Vision State developed an Internet of Things button used for medical clinics in Vancouver, Canada. So what it does, it's a quick touch. It's a quick touch. Just a minute. I mean, give me one minute. Yeah, so this is a button, and then the Vision State company developed this. This button has nothing. You just press the button, and there is a location here. This location is transmitted to the central server, and somewhere what is the message going on? The message going on is that you may require some cleaning, you may require some kind of sanitization, or you may require some kind of disinfection, and that, or you may require some kind of help. So you press this button, people come to you. And this IoT button actually, because it is coming from so many devices and all these things, so it creates that how many people are requiring help and all these things. So this is a company called Vision State, which is there in Vancouver, Canada. If you look at this, that's what I'm saying. Civil aviation department these days are not doing well, but the drone business is doing very, very well actually. You don't get even drones now. I wanted to buy a drone, etc., but they are not available these days. What is this unmanned air vehicles or drone-based scanning actually? So if you look at this actually, drones come. So drone dispatch module will be there. So drones come, they gather the data, they take the images, they take the drones are fitted with thermal camera. If you look at the right side, there is a drone. In the drone, there is a thermal imaging sensor and there is an imaging sensor also. Now, if the drone, so you know this thermal imaging, of course, the thermal sensors are very costly here because they have to observe from a distance. Now, if they find out a hot body, I repeat, a hot body means which radiates temperature or which radiates heat. Now, when the sensor, the thermal imaging finds out a hot body, this particular camera, the camera means another optical camera, will take a picture of that and fuse it with the hot body and send that to the central server. So if you look at this actually, the diagram here, there's a drone will be moving around in any kind of a marketplace or somewhere. It keeps on monitoring the temperature of the people underneath. Whenever it detects a hot body, it takes a photo of that and send it to the cloud or the storage where there is an alert notification or notify that high temperature, face and other things can be done. Now, if you, I'll come to that. What we did actually, how do you do it? I mean, it's not very difficult thing actually to do it, but we have not done that, but we have done a similar experiment where we implemented a drone-based module to monitor human safety. Now, what is human safety? Suppose some woman needs some help, then they press a button And when they press a button, the Hyderabad police station, there will be some drones. The drone will fly and try to take a picture and a video for 1 minute. Now see, this is why I'm doing. There are 2 students who came to me for intern. They developed this and they gave a demo to the Hyderabad police also. Now there is some message has come. So this drone will go. We'll try to take an image. So this was a kind of a demo in the Hyderabad police ground. So it comes, wherever there is a gathering, it gives a kind of a police siren and then takes a video of that and goes back actually. Sorry. Yeah, it comes back. Yeah, I want to stop here and tell you that these are the 2 boys actually, this boy and this girl. They were doing some internship with me and they developed this model that a drone can be dispatched, can take a photograph, can come back and all these things. Of course, it's not fitted with a thermal image, but then the entire thing is ready. Once you fit a thermal image, thermal camera, thermal sensor, it will also try to find out the hot body. So this boy and this girl, they were the students behind this, doing this actually. Yeah. So the same thing, there is the same model actually, particularly in China, there is a company came up and they said that they developed a helmet actually. If you look at the helmet, look at the both things. There are 2 things here. If you look at the helmet, there are 2 ear kind of a thing. So in the ear here, it says that there is 1 ear is a optical camera, the another ear is a thermal camera. So if you wear this helmet, I mean the police will wear the helmet, etc. They will try to find out when they go in a motorcycle or something, they will try to find out that if there is a person with high temperature or there is so they take the image, they take the person and send it to the cloud storage. The same model actually, the same model here, the smart helmet system for public screening. The helmet will send the signal. If you look at the right side figure, there is a helmet. So the helmet, the person will wear the helmet. It will detect a hot body. Once the hot body is detected, it will take a picture also. And the picture will be sent to the cloud so that the necessary police or the health workers will take care of it. The same model is for smart glass also. There is a smart glass. The smart glass, you wear the smart glass. The smart glass will also have an optical camera, will also have a thermal camera, will also have a headphone because it will tell you something. There is a Bluetooth module. And then whenever they detect, suppose I wear this glass, and if somebody is approaching me nearer to that, I can measure its temperature actually, its body temperature, how close it is because there is a Bluetooth module. So I can maintain the physical distance. I can measure the body temperature of the person who is coming close to me, and I can also see. Look at this. There is a smartphone kind of a thing. So this information can be fed to my smartphone, and my smartphone says that the temperature is 38.5 degrees centigrade. This is the location. This is the date. This is the time. So everything I can store actually. And if I'm infected, the police will come to know that okay, at this point of time you had this person. This is the photograph and all that. So this is also a model which people are using. Now, what I think I told you, I think I'm almost close actually. You give me another 5 minutes time. So what is a contactless control system actually? Because we want everything to be controlled. I want my TV to be controlled, and my remote to be controlled. I want my lifts in the escalators in my society to be controlled, and I don't want to touch them because the touching is forbidden these days actually. So how do you do? If you don't want to touch, you have to gesture actually. Now, when you do a gesture, that means suppose I want to go to 7th floor, right? I go to the lift, I come inside the lift and gesture that is 7. In my hand, I say write 7. Now, if I write 7, then if there is a camera, then it's okay. But if there is no camera, and the camera, image processing, vision processing, etc., are quite costly. I mean, costly in the sense computational intense. So they don't work in real time actually. So we thought of that, can we do some kind of an accelerometer sensor, machine learning, etc., so that we can, this gesture can be recognized. So what is the contactless control actually? It opening of door lock, opening of a lock actually. Suppose you have a digital lock in your home and you don't want to touch the lock and all these things. You want that key, you will give a password or a pin. The pin will be recognized and then the door will open. So what is the pin? Is a continuous 4 digits or a digit with the alphabet, etc. So that should be recognized actually. So the server identifies the pin, and if it authorizes, it opens the door and the lock without touching. So you can touch, you can operate the lifts, you can touch, you can operate the locks, you can operate many devices which you don't have to touch, but through your gesture. You just, for example, I've shown you one slide. You gesture that your hand is moving and the temple bell will ring, but that is camera based. This is not camera based. This is you wear a device and that device will gesture. I mean, the way you move your hand, it will try to recognize it. Now, I don't want to go into the details, but see a small demonstration. This is done by my student only. So now look at this. So this is a device which will be like a ring actually, which you will wear it in a ring. See, he's trying to write H, but this is wrongly detected as a 4. He's writing Y. It is wrongly detected X, but after that, everything is safe. This is Y. It is recognized as Y. Wait a minute. I don't know why it is happening like this. I think the video has some problem, but I don't know. So what is basically I'm trying to say that this is a device which you can wear in a finger, and then in that finger you move your hand. What do you want to say? If you want to say this, you want to say 8, you write 8, and you see there is no camera, there is nothing here. Based on your movement of the hand, and we have trained it actually. We have trained that you move your hand like this, it is 8. You move your hand like this, it is 7. You move your hand like A, it is A. So you can communicate to the system or you can controller without talking or without a camera, because camera, suppose I'm in the bedroom and I don't want a camera to be in my bedroom, but I want to communicate that my bedroom door should open, my toilet door should open. So for contactless control, a gesture-based IoT-enabled machine learning embedded technology is this. So this is not required. I mean, it's almost there. So what you do actually with all these things, you can build a volunteer community. So what you do actually, it allows the volunteers online alert central station. So we thought that okay, if you can use a helmet, if you can design a helmet, or if you can design a smart glass kind of a device, then there can be volunteers on the roads, in the supermarket, in the malls, in the cinema halls, etc., who can just monitor people, because you don't have to have police and all these things. It will take a photograph, it will detect the hot body, it will detect the temperature, it will take a photograph, it will upload it to the server. So wherever there are some issues, the police or the health workers can go and find it out. So this is basically a crowdsourcing based model by which you can build a volunteer community to help the government or the healthcare workers or the service providers to build this. So all these things what I have discussed with technology, with everything. So we have written a book for the researchers, academicians, and also industry professionals. So how it will look like. So the title of the book is Internet of Things and Sensor Network for COVID-19. Me and one of my colleague, Dr. Nagendra Kumar. So we have co-authored this book. So if you have time, I think it is free now for 7 days or 10 days. You can download it and see that also. So this talk is basically not everything in the book actually, but most of the things are in this book. So you can look at this, read it for more details and all these things. So let me conclude my talk. So we tried to discuss the development of sensor technology and IoT framework, how it is helping the already stressed healthcare system, how can you reduce the burden on them. We discussed about the COVID-19 management protocols, like social distancing, like quarantine, like hand sanitization, like hot body temperature, like mass screening. You can detect a mass screening, etc. We discussed how industries, we discussed about industries in Canada, we discussed about industries in United States, we discussed about industries in Italy, how they are geared up to meet the challenges, even the Tirupati temple, how they are geared up to the challenges. And we also discussed few existing systems and potential applications, right, touchless control and all these things. I think, thank you very much. And for all these things, there are few people who have worked with me and also contributed to the development. Dr. Nagendra Kumar, Rahul, Mrityunjay Anurup, and Pragya. These are the two guys who developed that drone-based system. Somaya Abdut, he helped us to develop the gesture-based control system and all that. So thank you very much. I don't know how long, how far I was audible, wherever there was some disturbance, etc. But it's a good to talk to you all. Though I'm talking to my laptop, but it's always good to talk to you.
Okay. Thank you, sir, for this wonderful talk. Now, let us go for this question answer session.
Yeah.
One question has come from our faculty regarding what temperature it monitors, but he doesn't mention that what he is referring to.
I can see one question here where I think Dr. Vignesh Sharma or Mr. Vignesh Sharma, he was trying to say we talked more about sending the data to the centralized server. So it is imperative that the centralization is necessary. But in India, we don't have many healthcare organizations that provide end-to-end solutions, like from clinics to labs to pharmacies to ambulance services, etc. So the healthcare is disoriented. The Internet of Medical Things, we can align these healthcare services. But is it possible to bring interoperability between these organizations? I mean, there is going to be data sharing if this is implemented. How likely the various verticals of healthcare organization will open up for this change? Okay. Thanks for asking this question, actually. Now, if you have followed Vignesh, the whole idea of, I think at some slide I said that it's an edge cloud architecture. Internet of Things is basically an edge cloud architecture, means it is not necessarily always server. It is sometimes it is at edge and sometimes it is at a cloud level or server level. Now, if you depending upon, I think that's where the techno managers are coming up, depending upon the situation, depending upon the requirement, depending upon the facilities you are available, either you deploy the model at the edge to the maximum, that means thick edge and thin server, or you make it thin edge and thick server. So that depends on how good is your support system, actually. So if I don't have a good centralized server system, I would like to put my intelligence, put my decision-making capability at the edge at the maximum and less on this server. And for that, the training, etc., has to be done accordingly. Now, interoperability is a big challenge. I mean, it's a huge challenge. Interoperability is a huge challenge because one hospital, now also you know, right? If I take an X-ray of my chest in one hospital and I go to the other hospital, they ask me to repeat the test again because they don't believe in the previous test. So interoperability is a big challenge. I think the healthcare industry, the health officials, the health administrators, they have to come together and do it. We as a computer science or electronics people have very less role to play here.
So another question has come.
Yeah.
What kind of centralized gateway to manage and monitoring the devices? Okay.
Again, you are coming back to this centralized gateway. So I would say that there is I think people are aware of it, SCADA. The SCADA protocol is being used to manage the data at the centralized server. SCADA is basically a data acquisition algorithm, scalable data acquisition algorithm. SCADA, SCADA. Anything else? I see 3 questions actually, but I'm not able to see. Hello?
Hello, sir.
Yeah. There are
any question?
There are 3 questions, but I'm not able to see. Yeah. Okay. Somebody has written a very good thing actually. Will it increase or it can increase the risk of electric shock? And if you try to touch the appliance? Oh, definitely not. These appliances run in millivolts actually. Microvolt, millivolt, etc. So there is electric shock kind of a thing is not there. They don't work on 220 volt or 440 volt, etc. So electric shock is minimum. what is probably the question in a different way that it will does, say for example, whenever you have a wireless communication, so there is an electromagnetic wave actually. So the electromagnetic wave has its effect on the health of these things. But see, these days we are used to smartphones actually. Every time, I mean, 24/7 we have a smartphone with us, and smartphones electromagnetic wave is much more stronger than these devices actually. They are very small. They are very little. Bluetooth is much less in power compared to the smartphone actually, because Bluetooth communicates only to 7 meters or 10 meters. But your smartphone communicates to up to 2 kilometers, 3 kilometers, 4 kilometers to the tower actually. So the electromagnetic the radiation is much more in the smartphone compared to these devices. That is one. What temperature it monitors? Basically, hot body temperature actually. It doesn't monitor. So, for example, if you look at body temperature, usually people put thermometer inside under the tongue or under your armpit, etc. It doesn't do that. But what it does actually, we try to correlate that if it is the temperature outside the body. Say, for example, we have filed a patent also. How do you know that somebody has suppressed its temperature using paracetamol tablet or washing your face? If you go and wash your face 10 times, then this thermal scanners will not be able to detect it actually. What normally happens, I mean, I may be permitted for 1 minute. What normally happens is that when you scan your body temperature in your face also, the temperature is not uniform. The temperature is less when if the area is exposed, and if the area is exposed, because there will be sweating. So if the area is exposed more, the temperature will be less, and the area is exposed less, the temperature will be more. For example, your forehead temperature will be little less than the temperature below your nostril or below your lower chin. So what people do when you wash your face, normally what happens is that it becomes uniform. So if you have a thermal scanner camera or thermal scanner sensor, if you scan your face and if you find that there is not much of a variation in the temperature, then you know that this is suppressed by medicine or by washing the face or by some artificial measure. But in a normal temperature scenario, you will find a gradient of temperature there. So that's what I'm saying. So when you say what temperature it monitors, it monitors the body temperature, but we don't measure the temperature under your armpit or below your tongue. We measure the temperature which is exposed, but that is correlated, compensated, so that if this is the temperature, what will be the exact body temperature? So that formula is modeled, is learned actually, in fact.
Okay, sir. One question from my side, that is, can we use a drone to identify the areas which are highly affected by COVID, something like some percentage of geographically located area?
That's what exactly I said. There are some very high sensitive thermal imaging sensors are there with a lot of resolution, which can measure a group of people, the temperature of a group of people. So for example, if you take 320 by 320 resolution thermal sensors, it costs around 5 lakh rupees, but it can measure a complete group of people, some for around 40-50 people at a time. Now, what is the advantage that it will not measure whether they're COVID infected or not, but it can measure hot body. Suppose there is a group of people, let's say Dharavi or something in Bombay and all that. And when people are outside, etc., the drone can move around and can detect the hot bodies. Now, if you feel that there are so much of hot bodies, so many hot bodies around that area, then this is highly infected, possibly. And that's what the protocol says now, that body temperature is one of the indication actually.
So some clustering algorithm can be used to
very easily clustering algorithm can be used. You can detect a group of hot bodies. Now people are saying that when the office will open, etc., or the supermarket will open, people will be scanned entry. Now you see the thermal sensors which is available now, or the supermarket people are using now, each one, if you scan it, it will take some 2 seconds or 3 seconds. Now imagine that in a particular day, suppose there are some 5,000 people will come to a mall, how much time it will take to scan? So that's not possible. So you need to have a thermal camera kind of a thing, thermal imaging camera, and an optical imaging camera. People will just pass through, and this camera, the image camera, will give a heat map kind of a thing. So from the heat map, you superimpose the optical image and try to find out the faces. That's what people are doing.
Sir, another interesting question came, that is, can we develop any mask which can give information about the health of the mask to stop reusability of the mask several times?
No. Okay. I don't know, but people are trying to talk about it actually. Health of the mask, say for example, we also tried, but we are not able to zero down on the model actually, because masks need to be washed. Masks need to be, so you have to also look at those that design aspects. Mask health, I don't know, but masks are being used to detect the health of the wearer, whosoever is wearing it.
Sir, okay. And that's
So Vikram, let me tell you what happens actually. So there are some chemical sensors. They put it on the top of the mask or behind the mask. So when when your body temperature rises, or when you cough and other things, that gas actually, the color of the mask changes.
Exactly.
So looking at the color of the mask, suppose it is green. Let's say it is green. When your temperature becomes let's say 100, the green will change to red. So that looking at the color itself, you can know that okay, my body temperature has changed. Or even if that guy is not saying, you can look that okay, this mask he is wearing and it is red, so he is suffering from fever or something.
And we have to change the mask also, maybe.
Yeah, you
We can need to change.
mask.
Acha, one question that is challenging question. Okay, what do you think? What do you think the IoT can completely replace the human mind and take its own decisions?
Okay, let me tell you. I mean, and one small. The answer is like this. When I was a young faculty and before I got married, etc. So after I finished my university work, I normally go to a park and I sit with friends and then come back home. Many times I used to eat outside also, because you eat some burger or some cola or something and then come back home. Now, when I come back home, my mother will be waiting for me, because at that time they used to wait until the son and the husband they eat. They don't eat actually. When I come back home, actually, I normally don't tell her that look, I have already taken and all this thing, because she doesn't feel good actually. So the way I walk in, I put my bike inside, and the way I walk in, etc., she will come to know that I have already taken food outside, and she will serve me little food. Now that kind of intelligence will take, I mean, thousands of years for a human or a machine to replace it actually. So don't worry, human beings human beings will never be replaced. From your footsteps, from your coughing, I can know that you are coming. He is Bikram, he is so weak and other things. It will take another 100 years for the machine to learn that. From your footsteps, I can find out whether you are hungry or not. Machine will never be able to do that actually. So don't worry about that actually. It will never...
Okay, thank you, sir. Any more questions from participants? Okay, I think
some 8. I mean, you might be seeing them. I'm not able to see.
No, yeah, I've just read the questions here. Okay, now I request our director, sir, to give his concluding remarks.
Yeah, am I
yes, sir. Yes, sir.
Okay. Thank you very much, Dr. Professor, for your wonderful webinar talk today on a very, very important topic of IoT. Well, you started with a very good definition. What is the difference between a smart man and a wise man? You have rightly said that the difference between smart man and a wise man is that a smart man knows what to say and a wise man knows whether or not to say. Precisely the electronic sensor system that you explained is based on this definition.
Yes, yes.
And thereafter, you explained the model that explains the smart sensor systems. And you have rightly mentioned that sensor is everywhere in the world. Whether it is, you talk about a smartphone, you talk about iPad, you talk about laptop, you talk about telephones, everywhere sensor is there. And they give intelligence and they transmit the intelligent data. And so therefore, it is very important for us to know about how does this sensor system work in an IoT framework. And therefore, why it is so useful for the industries today, post-COVID-19 period, to understand about the impact of these things which is happening around us. You have rightly said that IIoT enables industries and enterprises to have better efficiency in the operations, which you have explained with several examples. And various technologies which are being used in this type of the enterprise architecture or the sensor enterprise architecture are the widespread use of the technologies. For example, cloud computing, edge computing, data analytics, artificial intelligence, machine learning. But apart from these three, the artificial intelligence and machine learning that you have explained with various devices, and how those devices, including drone, really do a fantastic job in terms of identifying the COVID patients, or identifying the patients who with high temperature, body temperature, etc. So I think a major breakthrough in the machine learning, in fact, through these technologies has happened now. And what Bill Gates had said, that a breakthrough in machine learning would be worth 10 Microsofts. And I think it's quite right today, and that is happening now on this earth. Various models, Professor, you have explained these models in a very simplified way. So, for example, you said that on the one hand we have data or output in machine learning, and then how does this computer does this modeling, and then the output is the program, and therefore this model, in fact, how it is being used by various devices to identify the pandemic situations, and how is it useful for the health workers, including police, in policing and monitoring the pandemic situations. But most of all, the most important thing to my mind that you explained at the latter part of your lecture was about the use of various technologies. You talked about ultrasonic inspired technology, magnetic flux sensor, smart watch and Bluetooth signal strength, gesture-based technologies. And I think that these are the 5-6 technologies which have been used by various companies today in India and outside India, and including US and Europe, which are giving a lot of help and support to the individuals as well as to the health workers to identify the COVID pandemic impact. DRDO, for example, you said that has come out with this kind of device, which is very useful for the police in identifying all these things. So therefore, your talk, and congratulations for the publication of your book. And I think it should be read by every student and every professor if they want to understand about the new technology that has happened, which you have already captured. And also, I'd like to express my thanks to your professor, other co-partners, and the students who have really helped you in developing this technology as well as in writing a book. So congratulations once again for publication of this book, and thank you very much for your wonderful insights on a very, very important topic. And I think the young minds, the students, must have been immensely benefited by your lectures. Thank you. Thank you so much.
Thank you, sir. Thank you very much for your.
Thank you, sir.
Thank you. Thank you so much.
Thank you,
Thank you, sir. Thank you all. Thank you, Director, sir, as well as Udgata, sir, for a nice talk. So good night.
Thank you very much. Yeah, I enjoyed it actually. Thank you, sir. Thanks. Thank you, Director, sir. We see you some other time also.
Good. Yeah.
Thank you, sir.
I think Dr. Vikramjit, I think Dr. Siba should be invited in the campus.
Sure. Yeah.
Or even in some of the courses, like the courses that you will